All right, so question 6 about a person who takes out a loan, a $1,500 loan, 12% interest per year, and 2-year term. So we know that that's going to be 24 equal payments, and we're going to call the value of the payment X. Okay, so the way to build this up is to try to think about it 1 month at a time, and then see if you can extract some sort of a sequence out of it. So what I can do is make a little bit of a table here. So um, let's call this the payment P here, and X can be the months, and then Y is the amount owed. Okay, so what's going to happen is in month 0, the amount owed is 1,500. Then in month 1, two things happen. You have $1,500 times 1.01, and I got 1.01 by taking the R value and dividing that by 12. So that's 1% per month. And you also made a payment. So subtracting the payment P. Then in month 2, everything that happened before 1,500, 1.01 minus P gets multiplied by 1.01, and you have another minus P at the end. Same idea. Number 3, we would take everything that we had before, 1,500, 1.01 minus P, 1.01 minus P times 1.01 minus P. And so what we're going to try to do is see if we can extract some sort of pattern. So I'm going to rewrite number 2 like this. Distribute the 1.01, so I get 1,500 times 1.01 squared, then minus P times 1.01 minus P. The third year is going to be 1,500 times 1.01 to the third power minus P times 1.01 squared minus P times 1.01 minus P. So what I'm noticing is that the number of months matches up with the power on the 1.01 attached to the 1,500. So see 2 matches 2, 3 matches 3. And then after that, there's geometric sequence involving the p-values. So here we have just one term. Here we have 2 terms. Here we have 3 terms. Okay. So if I extend that pattern, then I can think that pattern number n is going to be 1,500 times 1.01 to the n minus P 1.01 to the n minus 1 minus P times 1.01 to the n minus 2, etc., all the way down to minus P. So we care about the 24th month. So let's set up the 24th month. So 24 would look like this. 1,500, 1.01 to the 24. All of these other terms in the geometric sequence have a P in common. So I'm going to just write minus P times. Then we have 1.01 to the 23 plus, because I distributed out the minus 1.01 to the 22, all the way down to plus just 1 at the very end. In other words, 1.01 to the 0, if you want to write it out like that. Okay, so then we know that this needs to, one second. Yeah, so we know that this needs to equal 0 because you're supposed to pay it off at the end. So let's set this all equal to 0. And then if you solve, what you get by adding the p over to the other side and then dividing by the geometric sequence is that the p is going to equal 1500 times 1.01 to the 24 divided by that geometric sequence, which we can have here be G1 equals 1, and then there are 24 terms, so G4 equals 1.01 to the 23. And so down here, I'm just going to say S24, and we'll calculate that separately. So let's use our geometric formula. So S24 is going to be the first term times 1 minus R, 1.01 to the N, 24, divided by 1 minus R, and that equals, let's see, 1 minus 1.01 to the 24th, and then divide that by, and I get 26.97. And so then my P, my payment, just calculating 1500, 1.0 raised to the 24 divided by the answer I just got, and I get 70.61. Okay. Great. So then that's part 1. That's the payment. And then part B, how much does he actually need to pay? So there's 24 payments of that. So I just multiply by 24. And the total payments, let's just do that up here. Sorry, it's a little messy. The total equals 1694.65. Oops, they said to the nearest dollar. So 1695. So it looks like they paid about $195 in interest over the course of the loan. So there you go. That was question 6. Comment, ask questions if there's anything that I could do better. Thanks.